Look at example 4. Here we have an application. It says, when an object is spinning in a circular path of a radius 2 meters with a velocity v in meters per second and centripetal force acceleration a in meters per second squared is directed towards the center of the circle. The velocity v and acceleration of a are related by this square root function. V equals the square root of 2a. I want to graph the function given that a is greater than or equal to 0. I want to know what the centripetal acceleration of an object spinning along the circular path with a velocity of 4 meters per second. So we'll start here. I'm going to do a and v this time. Whoops, need a pen. So a and v. I'm going to start at 0. 2 times 0 is 0. The square root of 0 is 0. Then I notice if I do 1, I'll get a square root, I'll get a decimal, which again is fine. You can graph a decimal. I'm just not going to do that. So I look at my perfect squares. If a is 2, 2 times 2 is 4. The square root of 2 is 2. Then if my next square root would be 9. Well, that would be decimal for a, won't it? So after 9, my next square would be 16. So if I make a 8, 8 times 2 is 16. The square root of 8 is 4. That should be enough to get our graph. So I'm going to start at 0, 0, over 2 and up 2, and over 8. There's 2, 3, 4, 5, 6, 7, 8, and up 4. 1, 2, 3, 4. And then notice when v, I want to know when the velocity is going to be 4. So if I put 4 in for v, I get the square root of 2 times a. Well, let's talk about how you're going to solve that. Well, I'm going to square both sides. Oh, in fact, I already answered this, didn't I? You can see it. It's on the graph. When is v4? Right here at 8 and 4. So after an acceleration of 4 meters or 8 meters per second squared. So let's continue this on. So equals the square and square root, they cancel each other out. So 2a equals 16. Divide both sides by 2. And I realized I'd already done this in my table. A equals 8. So that answers your question. And this would be 8 meters per second squared, because that's how we measure acceleration in this problem. We know that because it tells us in the problem, if you're wondering. Meters per second squared. That's how A is measured.